video for taking the product rule of a function. So product rule basically is when you have a derivative where a function is going to have two or more functions multiplied together. The key word here is multiply. Now, like you guys have in your packet, there's six trig functions, and then four exponentials. Okay, six trig functions and four exponentials. Okay, and all it is like the shortcuts of the derivative is. So, for example, the derivative of the sine function is cosine. Derivative of sine function is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared of x. The derivative of secant x is secant x tangent x. The derivative of cosecant x is negative cosecant times cotangent of x. And the derivative of cotangent of x is going to be negative cosecant squared of x. Okay, now easy way of matching these up. Derivative of sine is cosine, cosine sine. Okay, they're reversed. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. So you have secant squared, cosecant squared. Derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. So secant tangent, cosecant cotangent. They kind of match. There's a pattern to it. Now notice when you're taking the derivative of anything that has a c in it. Derivative of cosine is negative. Derivative of cosecant, negative. Derivative of cotangent, negative. So basically, if you have the three main ones, sine, tangent, and secant memorized, the derivative of the co in front of it, just change it to cosine instead of sine. Cotangent, cosecant cotangent, and cosecant, and if it's a negative out front. So if you're taking a derivative of a trig function, there's no c in the front, it's positive. If you're taking a derivative with a c in the front, it makes it negative. Just try to think of a way to help you guys memorize that. Now, derivative of natural log function is 1 over x. Okay, I'm not going to prove it, just be able to use it. Derivative of log base anything of x is 1 over x times the natural log of the base. Now for exponentials, derivative of a number to the x power. So x is your exponent, so the derivative is natural log of that base times a to the x. And then e is the easiest one. Derivative of e to the x is just going to be e to the x. And we proved that in class last Thursday. Okay, there's a proof of that in your notes. Why this is the way it is and why that one is the way it is. Now, just using product rule, okay? Product rule is basically taking a derivative of something, of a function that consists of two or more functions multiplied together. So example, I have a cubic function multiplied by a quadratic function. Two polynomials multiplied together. Now, with this kind, you can either FOIL it and do the derivative, or just use the product rule. Now, the product rule, all you do is you take the derivative of one function, one part at a time, and then you leave the rest alone. So, for example, part number 1. So, I'm going to take the derivative of x cubed plus 2, which is 3x squared, and then you leave the rest alone. And you add that to take the derivative of the second function, because you do one part at a time. So we did the first part. So I did the derivative of that, left the rest. Now do the derivative of the second part, leave the rest. Okay? So I have all that. Now from there, the derivative calculus is done. Now it's just algebra. Distribute, and then simplify. And you can do that part. Okay, more examples. Okay, product rule. X to the 30th times sine of x. It's multiplication. Two functions multiplied together. So again, for the derivative, take the derivative of x cubed. That's the derivative of the first part, and then leave whatever else is behind it. Sine of x plus. So I did the derivative of this guy. Done. Now I do the derivative of the second part. Cosine of x. So I did the derivative of cosine, and then you leave whatever else is around. So I just did sine by itself to get cosine, but I have x to the 30th. So yeah, that's it. So for product rule, you take the derivative one piece at a time, and you leave the rest of it alone. Okay, another example. E to the x times natural log. Product. So I do derivative one at a time. So I'll do derivative e to the x, and then leave everything else. So the derivative of e to the x is e to the x. So I did the derivative of the first one. Derivative, leave the rest there. Plus, now do the derivative of the second piece. Derivative of natural log from up top. Derivative of natural log is 1 over x. So the derivative of natural log is going to be 1 over x. So I did that. Now leave, and then whatever else is around it, I just have e to the x. Write it there. So if I want to simplify this, one over x times e to the x would be e to the x over x as your simplified answer. Okay, another example. Okay, y equals sine cubed of x. Now sine cubed, think of it this way. It's sine times itself 3 times. So this is y equals sine of x times sine of x times sine of x. 3 times. So when I have, again, 2 or more functions, you do the derivative of only one of them, leave the rest, plus do the derivative of another one, leave the rest, plus derivative of another function, leave the rest. So, for example, I'm going to do derivative of the first one. So derivative of sine is cosine. And that's from, again, above. All you basically do is just know that. Derivative of sine of x is cosine of x. So derivative of sine is cosine. You leave the rest. Plus, now I'm going to do derivative of this guy. Derivative of sine is cosine. And then you leave the rest. So what is the rest? Sine and sine. And last, take the derivative of the third piece. So if I leave the rest, sine, derivative of sine is cosine, and that's your product. The calculus is done. Now, the only way to simplify this is notice I have the same thing 3 times. Cosine, sine, sine, cosine, sine, sine, cosine, sine, sine. So how many cosine, sine, sines do I have? 1, 2, 3 of them. So my derivative is going to be 3 sine of x, cosine of x. So now sine times sine is going to be sine squared of x, cosine of x. That's going to simplify it to that. Okay, another example. Again, 3 functions multiply together. X to the 5th times the tangent of x times 7 to the x. Okay? Of a polynomial times a trig function times an exponential. Okay, so just do one at a time. So my derivative, do x to the 5th by itself. So derivative of x to the 5th. Leave the rest. That's done. First part's done. Now, we're going to do derivative of the second part. Okay, derivative of the second part. So I have x to the 5th. Derivative of tangent of x from the other side is secant squared of x. So I did the derivative of the second one, then leave the last. Then plus, now we're going to do the derivative of the third part, 7 to the x. So what I'm going to do is leave the first pieces and do the derivative of the last piece. So derivative of 7 to the x, natural log of 7 times 7 to the x. Okay, it's just from your shortcut from the front page there of taking the derivative of an exponential. Derivative of this is going to be the natural log of the base times itself. Now if you notice all of this, none of this has anything in common, so that's going to be your final answer. That's your final answer. Okay, number 5. Okay, natural derivative of natural log times cosecant of x. Same thing. Take the derivative of one of them, leave the rest alone. So derivative of natural log is 1 over x, leave the rest. Plus the derivative of the second function, so I'll leave natural log there. It's already took its derivative. Now do derivative of cosecant of x, negative cosecant cotangent of x. Again, derivative of something with c makes it negative, cosecant cotangent, and that's it. The calculus is done. Now just simplify it. So 1 over x times cosecant, okay, thank you, is going to be cosecant of x over x. Natural log times negative makes it minus natural log of x cosecant x cotangent of x. Yeah, go in there.
No.
Okay. Alright, 2 more. Okay, number 6. Now this one I have is natural log of x times cosine squared of x times 3dx times log base 2 of x. So I have 1, 2, 3, 4, 5 of them. Okay, so now this one can be written out as natural log times cosine times 3dx times log base 2 of x. Okay, I can write it out that way because cosine squared, cosine, cosine. So again, now it's the same exact pattern like we did before. Do the derivative of one of them, leave the rest. So, derivative here of natural log is 1 over x. So I just did this one. Now, leave the rest. So cosine, cosine, I'm just going to write it as cosine squared 3dx log base 2 of x. So I just did the derivative of the first part, left the rest alone. Plus, do the derivative of the second function. So I have natural log of x, derivative of cosine is negative sine of x, and again leaving the rest alone. Okay, plus, now do the derivative of the third piece. Leave the rest alone. So I'm doing derivative of cosine again, but I'm leaving these other pieces the same. So I add, natural log, cosine of x. Now the derivative of this cosine is going to be negative sine, and just leaving the rest alone. Plus, now derivative of 3 to the x. So I'm going to leave the rest alone, but just do derivative of this one. So I have natural log, cosine squared, cosine times cosine, 3 to the x. So there's my derivative. Log base 2 of x. And last one, derivative of the last piece. So plus derivative is going to be 1 over x natural log of 2. Again, this is from the front formula. So this is all multiplied together. And then, again, you simplify this. Just clean it up a little bit algebraically, and that's your final answer. Okay, last one. Number 7. Tangent times sine. So derivative of the first. Derivative of tangent is secant squared. Leave the rest. Plus derivative of sine. I left tangent alone. And that's basically it. One thing you can do a trig to see if anything cancels out to simplify this is convert it into terms of sine and cosine. So for example, secant is over cosine squared of x times sine of x. Nothing cancels. Tangent is sine over cosine times cosine. Cosines cancel. So your final derivative, a little bit more simplified, plus sine of x. Okay? So again, here's 7 more examples, or 8 more examples I should say, of how to use the product rule.